moves to the right, we say it moves in the rightward direction, and when it moves to the left, we say it moves in the leftward direction. So, like this moving object is experiencing positive acceleration in the rightward direction because the velocity is increasing and it moves in the rightward direction. And from the graph, you can see the line issued by line of constant and positive slope. The next one is when the object experiencing decreasing in velocity. So it moves and it still moves in the rightward direction. So we say it is rightward deceleration, and it's shown by the line of constant and negative slope. So the next one is when there's increasing in velocity, but it moves in the leftward direction. So that's why it is in the negative region of the velocity. So we say it is leftward acceleration, and it's shown by the constant and positive slope. Same with this one, the only difference is the velocity is decreasing. So now what is shown by the area of the graph, which is the area under the graph. So it shows the displacement of a moving body. In order for us to know how to calculate the area, we need to know basic formula to find squares, rectangles, triangle, and also trapezoid. So first example here. The shaded area represents the area of the moving object from time 0 to 6 seconds at a constant velocity of 30. So in order for us to find the area of the graph, we need to know that it is a rectangle and the formula is base times height, which is 6 times 30. So the next one is so also the same thing, but now the shape under the graph is a rectangle, it's a triangle. So we know that in order to find the area of the graph, we need to half times the base and times the height. So the next one is if the shape of the graph is trapezoid, because it is from what you can see here, we only want to know the shaded area. So it is half times base times height 1 plus height 2. Height 1 is 20 here, and height 2 is 50. So basically it's half times, the base is 5 minus 2, which is 3, times 50 plus 20.
Okay. The next is the derivation of kinematic equation of constant acceleration. Okay, the kinematic equation can be utilized by predicting unknown parameter information about an object motion if other parameter information is known. The kinematic equation are valid only for any motion which can be described as being either a constant velocity or constant acceleration. If the acceleration is changing, the kinematic equation can never be used. Then there is the four kinematic equation. The first one is velocity. Okay, I will explain the equation of each equation. For the first one, v is equal to final velocity, v naught is equal to initial velocity, a is constant acceleration, but I put the 10 meter per second in case of free fall acceleration. T is the fall time taken, and x minus naught stand for the distance that the object travels. So the first one, the derivation of the kinematic equation. First one, we need to assume that constant acceleration, then we can define the following first order differential equation to derive the rest of the kinematic equation of constant acceleration. Okay, wait a minute. Okay, the first equation is A is equal to the rate of change of velocity, which means the dv divided by the dt. And then we use the first order differential equation by using the changing variable. Then A times dt is equal to dv. Then we can integrate both sides. And then to put the limit, we can assume additionally that in our object's speed is from v naught which is initial velocity to V, the final velocity, and in a time interval to T0 to T. Okay, so the